Developers of projects are losing hundreds of millions of dollars because they neglect to perform this simple action. Do you already understand what is being discussed? Then watch until the end to confirm your suspicions. And we continue to tell you about the important elements of developing a Web3 project. If you've already coded your own smart contract, it's worth learning about the stage of its launch, which is the audit. The scale of the problem related to insufficient smart contract audits is impressive. In the history of the crypto industry, there have been significant losses for projects that did not thoroughly verify their smart contracts. For instance, Euler Finance lost 197 million because they didn't check the check liquidity step in the donate to reserves function in the contract, allowing users to enter a state of liquidation and complete the liquidation process. Another project, SafeMoon, lost 8.9 million due to a hacker who exploited a public burn function in the contract which allowed users to burn tokens from any other address. This removed SFM tokens from the SFM BNB pool, artificially raising their price and enabling the hacker to sell them back into the pool at a high price. Numerous examples of hacking attacks on smart contracts can be provided because they can contain many vulnerabilities. The most common of these include re-entrancy attacks that can occur when a smart contract function calls an untrusted external contract, enabling that external contract to drain user funds or conduct other malicious actions by recursively calling the original contract. Integer underflows and overflows can occur when a smart contract performs an arithmetic operation that outputs a number that exceeds the current storage capacity, leading to incorrect calculations. Transaction order dependence attacks, front-running, mean that poorly structured code can reveal information about future purchases by the D app, which other users can front-run in order to lock in a guaranteed profit at the expense of the protocol. Also, there are a lot of different vulnerabilities such as gas griefing, force-feeding attacks, timestamp dependence, denial of service attacks, information and function exposure, Oracle manipulation. If you are not willing to risk substantial funds backing your project, you should learn more about how to undergo a smart contract audit. The audit of a smart contract is especially crucial for decentralized applications as the blockchains they are built on are immutable. If a code vulnerability results in the loss of user funds, those funds cannot be recovered. An audit is a process where a team of experts using specialized tools examines an application's code, logic, architecture, and security measures to identify any potential issues and risks for both automated and manual processes. Upon completing the audit, experts compile a detailed report describing the vulnerabilities found and possible ways to address these issues. The next step is the deployment of the smart contract, which is possible when the contract is deemed secure for both users and developers. Smart contract audits are conducted by various teams of experts, with some of the most well-known ones being Certic, Consensus Diligence, Cypherin, Hacken, and more. They use specialized tools to identify vulnerabilities in contracts. And what's the difference between these tools? Echidna, a Haskell program designed for fuzzing property-based testing of Ethereum smart contracts. Flint analyzes Solidity code for style and security issues and helps resolve them. MyThrill, security analysis tool for EVM bytecode that uses symbolic execution SMT solving and timed analysis to detect a variety of security vulnerabilities. Mythex automatically scanned for security vulnerabilities in Ethereum and other EVM-based blockchain smart contracts. Rattle, an EVM binary static analysis framework that uses a flow-sensitive analysis. Slither, static analysis of Solidity source code for security vulnerabilities and best practices. Solgraph generates a DOT graph that visualizes function control flow and highlights potential security vulnerabilities. Specification language and runtime verification tool that translates high-level specification into Solidity code. The audit process follows several stages, regardless of the expert team chosen. Typically, there are a series of mandatory actions during the audit. Step 1. Documentation gathering. You should freeze the code, i.e. refrain from making changes to it, and provide technical documentation to auditors, including the code base, architectural data, and other relevant materials. The auditor needs a comprehensive understanding of your code and project as a whole to provide accurate assessment results. Step 2. Automated testing. The initial code examination process is often referred to as formal verification. This stage, your code will be scrutinized for all possible states of the smart contract, and warnings will be issued for issues that may undermine functionality or security. Sometimes integration and modular tests of individual functions are also conducted at this stage. Step 3. Manual review. A team of security experts meticulously inspects each line of code, identifying errors and vulnerabilities. While automated tests are effective at uncovering code bugs, human engineers are better at detecting issues with contract logic or architecture, poor coding practices that technically pass automated tests, gas optimization opportunities, and potential weak points for common attacks like front-running. Step 4. Classification of contract errors. In the final report, both you and potential users can see the type of error in the smart contract and assess how detrimental it may be to the contract's future operation. Errors are typically classified into the following categories. Critical. Impacts the safe functioning of a protocol. Major. Centralization and logical errors that can lead to a loss of user funds or protocol control. Medium. Affects the performance or reliability of the platform. Minor. Inefficient code that does not jeopardize the application's security. Informational. Related to style or industry best practices. Step 5. Initial report. The initial report provides a brief description of code flows and possible ways to address these issues. Some auditors also offer their own code fixing services. After this, the final report is prepared. Step 6. Final audit report. At the end of the audit, a final report is prepared for your project, summarizing all the identified errors and suggested fixes for the smart contract. Violations are marked as either resolved or unresolved by you or the auditor team. Projects aiming to gain users' trust typically publish the report in PDF format openly, although many popular services also host these reports on their websites. Therefore, developers with numerous violations in their contracts won't be able to hide these facts. Be honest with your community. You must remember that a smart contract audit is not a guarantee of its security. However, you can enhance the security of your project by undergoing an audit and identifying fundamental errors before your smart contract becomes publicly accessible. So now you know that developers can lose hundreds of millions of dollars by not conducting an audit of their own smart contracts. In this video, we've explained how the audit process works and why it's essential for your project. To learn more about Web3 development for your own projects, watch our videos. Bye for now!